We're going to continue on 2.5 transformations. We are going to be writing equations and stretching and shrinking graphs. So we will be looking at stretching and shrinking. So the first thing I want to do is equations. Before we had graphs and we was moving them left and right and up and down. We were given the equation. Now we have to do the opposite. We have to write the equations ourselves. And we need to know the shapes of each graph if we needed to graph it later. But we're going to look at each graph and write an equation for it. So if I look at the first one, it has the shape of y is x squared, but upside down and shifted right 8 units. Upside down is the same as reflected or a reflection. When something is upside down or reflected, the graph is being multiplied by a negative. So the graph is being multiplied by the function is being multiplied by a negative. So if I know my graph, and we just have to remember that it's upside down, so negative goes in front of the function. So negative is multiplying the parent function, so it goes in front. Then it says that it's shifted right, so we know that anything that is inside of our grouping symbol goes left or right. So if it's right, it's always going to be minus a positive number. So it's always going to be a negative here, x negative, and a positive 8. And that's all the equation is for that one. It says the shape of y is equal to x squared, but upside down and the right 8 units. So it has to go inside of the parentheses. You have to remember to write your square on the outside. And that's all you can do for that. So if this was my basic parabola, it would just flip and it would move 8 to the right. So it'll go 8 to the right and then it would flip. So the second one, I have the shape of y is equal to the square root of x. And it says it's going 6 units to the left and down 5. So we know whenever something is plus inside, it goes left to the left. So it doesn't matter what grouping symbol that you have. If it's a positive, it's on the left. Someone has a question? And then, so you will write plus 6 inside. And then down 5, that goes at the end. So we'll go down 5 minus 5. For the third one, we have the absolute value of x. And it's going to the left again, so that's inside. So remember, left and right goes inside of any symbol, so it goes inside of a square root, any parentheses, absolute value. So plus 7 and then it goes up 2. So if it goes up 2, it's positive, and this is the equation. So y is equal to the absolute value of x plus 7 and plus 2. Now this one is the shape of a cube, and it's going to the right. So right means that it's a negative inside, and then 5. And then it's upside down, so the negative is in the front. So only thing you have to do is make sure you take a note of the shape that they want, and then you just have to do your horizontal translation. That's inside of your parentheses, your absolute value or your square root, and then you do your vertical translation, that's added or subtracted at the end. Any questions on right equations? Now we are going to look at, thank you. Now we are going to look at vertical stretching and shrinking. So if I have a number written in front of my function and it's greater than 1, it's stretching. So if I write a number in front of my function, say my function is y is equal to f of x, and I write a number multiplying my function, and it's a whole number, or a number that's greater than 1, my function or my graph is stretching. Now, if I were to write a fraction in front of my function, multiply it by a fraction, so if I take the absolute value of 1/2, which is 1/2, it's going to be greater than 0 but less than 1. So if I take it of a fraction, it's shrinking. So a fraction you can kind of see as it's cutting things in half, so you can associate that with shrinking it. And then if I multiply by a number that's greater than 1, it's stretching. So we only look at vertical stretching and shrinking. We're not going to do horizontal. So if I multiply something in front of my function, and it's affecting the y coordinates. So anything that's being multiplied to my function in the front is going to affect my y's. So let's look at this up close and personal. So I have this graph. They give me this graph, no formula on the graph, but they said that it's the graph of y is equal to f of x. And they want me to move this graph. They want me to either stretch it or shrink it. So in A, I have a number, the absolute value of 2 is greater than 1, or a whole number multiplying my function. So therefore, my graph would be stretching. It would be a vertical stretch. And then if I have a fraction multiplying my function, it's going to be a vertical, it's going to shrink. It's going to be a vertical shrinking. So I need to transform this graph by a factor of 2 for the first one and a factor of 1/2 for the second one. So let's just put that into play. So when I'm stretching the graph, the first one is a stretch. So the number multiplying in front is a 2, greater than 1. So I'm going to stretch it. And to stretch a graph, I need to take the points from the original one and multiply each y coordinate by 2. Because when something is multiplying my function in front of it, it's affecting the y coordinates. Therefore, I have to take the original point and multiply, make a change in my y's. So I'm going to multiply each y by 2. So I'm changing it, and the x's are going to stay the same. So I'm going to multiply each y. So in the first one, my y is 0. So 0 times 2 gives me 0. So that point stays there. Then my second one, my y is 2. 2 times 2 is 4. So my new y is 4. And then this one is 0 times 2, 0. And negative 4 times 2 is negative 8. And then the last one is 0 times 2 is 0. So these are my new points when I stretch the graph by a factor of 2. So just remember that you multiply each y coordinate by 2, and then you just graph. So I'm a graph. So my points are these are my new points. So I'm just going to graph. So 5 is about here. Negative 2, 4, 0, 0. And that's that. So this is g of x is 2 times f of x. So we know that it's a vertical stretch, kind of over here pulling up. Any questions on that one? So in this one, we have a fraction multiplying my f of x. So if you have a fraction, the graph is going to shrink. And again, if something is multiplying my parent function on my graph and it's affecting the y coordinates, so we need to multiply each one by half, or 1/2. So let's do that. Okay, so the first one, 0 times 1/2 is 0. Then the second one is 2 times 1/2 is 1. 0 times 1/2 is 0. -4 times 1/2 is -2. And then for the last one, 0 times 1/2 is 0. So now all my y's are new, and I just need to graph. So the graph is h of x is equal to 1/2 times f of x. Shrinking, since this is a fraction. And my new points are -5, 0, -2, 1, 0, 0, 2, -2, 4, 0. -2, 1 is -5, 0, 0, 2, -2, 4, 0. So it looks like that is the graph. So it's kind of close, but so any questions on stretching and shrinking? So just remember that you take the point from the original graph, and if it's a whole number, you multiply all your x's, all your y's by it. And your x is getting in the way. So you multiply your y's by it. Now this one right here has all the transformations that we did. And we're using the same graph. So I need to move this graph either left or right and up and down, up or down. You can't do both. Up or down, and I need this stretching and shrinking. So the thing is, you want to know, where do I start first? What transformation goes first? We kind of follow the order of operations when we do this type of transformation where there's everything embedded in one. We always use order of operation, meaning that you always start with your parentheses, your horizontal. So whatever you have in parentheses, you do that first. So if I was doing this, I would shift the 3 units to the right. Three units right. And then the next step, when I'm doing order of operation, I would do anything that's multiplying it next. So I would do this 2, even though it looks like a -2, but this is actually like a -1. That's our reflection. So we do that separately. So we want to do the +2. So we want to do a vertical stretch by a factor of 2. And then I'm still have this -1 multiplying. I want to reflect it, multiply by -1. And then now when I have order of operations, I add or subtract anything. So I have a +1. So I am going to add, well, shift the graph 1 unit up. I'm going to take all this information and move this graph, but there's a lot of steps because I need to change my x's. And then once I change x's, I need to do things to my y's. So let's see this in action. So I have my points from my original graph. Now the first thing I want to do my horizontal translation. So I want to move my graph, this graph, 3 units to the right. So to do that, I need to add 3 to all my x's. Because if I'm moving the graph to the right, the points are going to get bigger. So I'm adding 3 to all my x coordinates. So when I do that, now I have -2, 0, 1, 1, 2, 3, 0, 5, and 7. So I added 3 to all my x coordinates because that's the only way that I can move it to the left or right. And since this is a negative, I always move it positive. So it goes to the right. Okay, so now I'm using the order of operations. I'm gonna go outside and multiply things by a +2. And I need to use the points, the new points. I'm not using the old points anymore because now I moved my graph to the right. So since I moved my graph to the right, my points are different. So if I'm going to do anything now, I have to do it to the new graph that I moved to the right. So there's a 2 multiplying by function. So I need to multiply each y value or coordinate by a factor of 2. So I'm going to get a vertical stretch. So I take my new graph because this one is new now because I moved it. Now I need to multiply these points by 2, the y's. So I need multiply 0, By 2, I get 0. 2 times 2, I get 4. 0 times 2 is 0. 2 times -4 is -8. And then 2 times 0 is 0. So now once I moved it to the right, I stretched it because that's the next operation that, follow the movement. So now I need to multiply it by this negative, because this is a -1. So it's being turned upside down or reflected. So I have to flip it over. To do this, I just need to multiply all my y's again by -1. So when I do that, so I need to multiply all my y's by -1. So now I have -2, 0, 1, -4, 3, 0, 5, +8, and 7, 0. So I added 3 to move it to the right. Then I multiplied by 2, my y's by 2 to stretch it. Then I wanted it to flip, so I multiply all my y's by a -1. And so now I'm going to move it up. And when I'm moving it up, I'm adding to it. So I'm adding to my y's. So I add 1 to each y. So I'm adding 1 to all my y's. So -2, 1, 1 and -3, 3, 1, 5, 9, and 7, 1. So when I graph my final graph, it's going to be these points right here, the last points that I did. If you were to look in the book, they graph each transformation, but I just graph. You just need to graph it at the end graph. So you just have to do all your transformations, and then your final points, you would just graph that. So let's see how that is going. So all my points I have -2, 1, 1, -3, 3, 1, 5, 9, 7, 1. Okay, so -2, 1 is about here, and then 1, -3 is around here, 3, 1, and 5 is right like around here, here, It's 7.1. And this is the graph. So this is the graph of one. So that's how you do your horizontal translations, your vertical translation, how to stretch and shrink the graph, and that would include 2.5.